Let's do an example of using traditional long division of polynomials. I happen to like this a little bit better just because it's not quite as algorithmic as the synthetic division, which means that I understand what's happening and why it's happening a lot better. But anyhow, it does take up a lot more space on your page, so here we go. I've got a full clean page ready for us. First thing you're going to do is make the little long division sign that you learned back in elementary school. And we're going to put, oops, that is not what it looks like. Let's see if it'll undo that for me. Yep. So it's neo, it's not a square root. It is a like that, long division sign. We'll just keep it wavy. And I'm going to put underneath it all of the stuff that's on the top in the numerator, just like always, like if we were doing regular long division. I take x cubed plus 2x squared minus 5x plus 7. One note, if you have a term missing, meaning like say I didn't have an x squared term, hold its place with just a 0x squared, something like that, just so that you don't forget that you have to use that term as well. So now I'm going to divide into that x minus 3. Now the process here is you're going to really pay attention to the x for the division, and then the other number is going to be for when you stop dividing and you take it back down to subtract out. So x goes into x cubed x squared times. I'm going to place that over the x squared term. All right, and then I'm going to now take that x squared term and multiply it back to both of these. The trick to that is that if I've done it right, then the first term should absolutely cancel out the leading term from before. So x squared times x is x cubed, and then x squared times negative 3 is negative 3x squared. All right, now we need to subtract. I can't impress upon you enough to watch your signs. You are subtracting in this method, not adding like in synthetic. Subtracting. X cubed minus x cubed gives us nothing, so I'll leave that spot blank. Then I have 2x squared minus a minus 3x squared gives me a positive 5x squared. And then bring down your next term, minus 5x. Now repeat the process. This time I'm going to take the x squared into 5, or the x into 5x squared. So that's going to go in 5x times, positive 5x times. And when I then take it back again, right, it's going to be positive 5x times x, which is positive 5x squared. 5x times negative 3 is negative 15x. And now when I subtract, negative 5x minus a minus 15x, that becomes a plus, and I end up with a positive 10x as a result. Carry down the next term, plus 7. And then finally, we'll finish out with x into 10x, that's an ugly color, plus 10. It's like a mustard poop brown. Blech. All right, so plus 10, and then I'm going to take this one back again like we did before. I'm going to take 10 times x, I get 10x. 10 times minus 3, I get minus 30. And we are subtracting. 10x minus 10x is 0. 7 minus a minus 30 gives me positive 37. So my remainder here would be 37 over x minus 3. And my polynomial that I got before that is x squared plus 5x plus 10 plus the remainder there. Now, there is one way that we can check our answers that doesn't involve Desmos, and that is to note the remainder theorem. And the remainder theorem, why am I using this color? Blech. Let's change color, shall we? The remainder theorem, I like that purple. Remainder theorem. All right, basically says take whatever you've used in your denominator, that 3 there, take the value of k. Remember we talked about x minus k when we were doing the synthetic division. Take the value of k and plug it into the original equation. So in other words, plug it in as x. So we're going to take f of k, basically. You could think of it like that, because if f of x was this guy on top, not the bottom part, just the top part, then we would take and evaluate that at 3 for our particular example, because down here, that's the x minus k. So k is going to be 3. So I'm going to evaluate my original function at 3. And so I get 3 cubed plus 2 times 3 squared plus 5 times 3 plus 7. If that is a correct answer, if our remainder is correct, then we did everything else right, because you're only going to get that remainder if you've done it right. It will tell us, because when we add all of this together, we should get 37. And let's see if we do. We get 3 cubed is 27 plus 2 times 3 squared. 3 squared is 9, so that's 18 plus 15 plus 7. I know that these two together are going to be 45. And then I've got, I think this was supposed to be a minus, wasn't it? It was supposed to be a minus, silly me. This is a minus right here. Goodness gracious, I talked to you about watching signs. I'm going to watch my own. All right, and it was a minus in case you didn't notice because of up here. You know, that minus. So 45 minus 15 is 30. 30 plus 7 is, yep, 37. Good. So we know that our remainder was right, which means we did the thing right. So that's another way that you can check your work.